5.4, solving radical equations and inequalities. This is on page 262 through 265 in your book. And our whole core concept here is really solving radical equations. So, to solve radical equations, you want to follow these steps. Step 1, isolate the radical on one side of the equation if necessary. Isolate the radical. Step 2, raise each side of the equation to the same exponent to eliminate the radical, and then obtain your linear, quadratic, or polynomial equation, which then we will go to step 3, and we solve the remaining equation using techniques that we've learned in previous chapters. Most likely just solving linear equations and quadratics. So, and then we're going to need to check your solutions on these. There is something called an extraneous solution, which you solve for it to be the correct answer, but when you plug it back in, it doesn't work. That will happen with these radical equations, quite often, actually. Okay, so let's go ahead and get started. Concept 1. Alright, so solve radical equations. Okay, so step 1, you want to isolate the radical. So in this 1a, I'm going to divide by 2 to both sides of the equation, getting rid of that 2 in front of the radical. And now I get the square root of x plus 1 equals 4 divided by 2, which is 2. Alright, next, what I'm going to do is basically raise both sides to the power of 2. The reason I raise it to the power of 2 is because really this is the square root, right? There's really an imaginary 2 there. So what happens on that left-hand side is that radical sign and that power of 2 cancel each other out, leaving you with just the quantity of x plus 1. On the other side, 2 squared is 4. And then I'm going to subtract 1 from both sides. And x equals 3. And voila, I'm done. And I'm going to go ahead and just verbally check it in there. I put 3 in there. 3 plus 1 is 4. The square root of 4 is 2. Times 2 equals 4. That works. Okay, so I'm going to move on to the next one. B. Cubed root of 2x minus 9 minus 1 equals 2. Isolate that cubed root by adding 1 to both sides of the equation. I get the cube root of 2x minus 9 equals 3. This time, I'm going to take the power of 3 to both sides to get rid of that cube root. And again, that cancels that and that. Now, I am left with 2x minus 9 equals 3 cubed. 3 times 3 times 3, which is 27. Going to add 9 to both sides. 2x equals 36. Divide by 2. And x equals 18. There's our solution. If I put it in there, I get 36. 2 times 18 is 36. Minus 9 is 27. The cubed root of 27 is 9. I'm sorry, the cubed root of 27 is 3. 3 minus 1 is 2. So it checks. Alright. I didn't take too long to check because in this case, most likely the answer is always going to work. The issue is where you get this radical on both sides of the equation, then we really have some issues a lot of times. But you do want to always check your answers here. And I'm going to ask that you go ahead and try number 2. Try number 2. Pause now because I'm going to go ahead and show the answers. Okay. The solution for number 2a is x equals 14, and the solution for number 2b is x equals 65. Okay, I'm going to go on to number 3. Okay. Concept 2, solve an equation with an extraneous solution. Okay, again, an extraneous solution is a solution you solve for it to be correct, but when you plug it back in the end, it doesn't actually work. Okay, it's not a valid answer. Alright, so in this case, I look here and I get this radical. It is all by itself. I don't need to isolate it, but I am going to go ahead and get rid of it by squaring both sides. Now on the left-hand side, we get this binomial squared. And it's the same thing as the quantity of x plus 1 times the quantity of x plus 1, which you could FOIL out. Although there is a shortcut, and my class last semester, if you're new to it, has been working a lot on this shortcut. So you take that first term, x, and you square it. You get x squared. You take your two terms, which is x and 1. You multiply them together, which is 1x, and then you times that by 2 or double it, and you get 2x. You take that last term, 1, and you square it. 1 times 1 is just 1. On the other side, or on the right-hand side, now that power 2 and that radical sign cancel each other out, leaving you with 7x plus 15. Okay, now I have this long equation. It is a quadratic, because I have that power 2 right there. So what I'm going to do is basically move everything to one side of the equation and solve. So I'm going to subtract 7x. I'm going to subtract 15 from both sides. And now I have 0 on one side of the equation. So I get x squared minus 5x minus 14 equals 0. To solve quadratics, we have many options: solving by factoring, quadratic formula, completing the square, and potentially even by taking the square root. In this case, though, I'm going to go ahead and do it by factoring. So I break it up to two binomials. Trinomials always factor into two binomials. And it's going to be x minus 7 and x plus 2. Two numbers that multiply to give me negative 14, negative 7 and 2, that combined to give me negative 5. I set each factor equal to 0. X minus 7 equals 0 and x plus 2 equals 0. It's called the zero product property. Gives us a lot of options. And now I just add 7 to both sides, subtract 2 to both sides, and x equals 7 and negative 2. Alright, but in this case we may have one that doesn't work, and I'm going to go ahead and show it right now. So the first check I'm going to do is for 7. Okay, so when I put 7 in there, I get 7 plus 1 is 8 on the left-hand side. When I put here, I get 7 times 7, which is 49, plus 15, which is 64, and does 8 equal the square root of 64? Yes, it works. It's good. I'm moving on to the next one. Let's check x equals negative 2. Alright, when I put negative 2 back into the original equation for x, right, negative 2 plus 1 is negative 1. When I put it here, I get negative 14 plus 15, which is positive 1. So is negative 1 equal to the square root of 1? Well, the answer is no, right? So I'm going to cancel out that negative 2 because it really does not work. It's an extraneous solution. The only answer that works is 7. So that's what you have to put. X equals 7 and only 7. Alright, you are going to do the same thing with number 4. Alright, please make sure you check your solutions for a possible extraneous solution. Alright, pause now because I'm going to go ahead and show number 4. Alright, here's number 4. The answer is 9 and only 9. Even though you solve for 9 and 1, 1 does not work when you put it back into the equation. Okay, let's go to concept 3. Okay, concept number 3. Solve an equation with two radicals. Okay, same idea, but this time you'll notice I have two radicals. So now, in order for me to get rid of those radicals, I'm going to have to square both sides here. And it's still not going to get rid of the radicals, but it's going to at least give me the option to then square it again to get rid of it. I know that's kind of complicated, but here we go. I take this first term right here, because this is a binomial squared. Same with that shortcut we've been talking about. I take this first term right here, x, the square root of x plus 2, and I square it. So when you square that, you are just going to get the quantity of x plus 2. The radical and that power 2 cancel each other out. I take my two terms, the square root of x plus 2 times 1, and then I double it. So it's going to be plus 2 times the square root of the radical x plus 2, or square root of x plus 2. Then I take my last term right there, 1, and I square that. 1 times 1 is just 1. On the other side of the equation, I take the square root of 3 minus x squared, and I just get 3 minus x. Okay. Basically what I'm going to do is isolate this radical right here. So I'm going to subtract x from both sides. Getting rid of, or off of that left-hand side. And then I got 2 plus 1 is 3, so I'm going to go ahead and just kind of combine these and subtract 3 from both sides. And that's going to cancel all of those. Alright, what am I left with? I'm left with 2 root x plus 2 equals negative x plus negative x, which is negative 2x. Alright, continue to solve. I'm going to divide by 2 to isolate this radical. If I divide by 2 to one side, I must do it to the other side. Now I am left with the square root of x plus 2 equals negative x. Alright, now I'm going to square both sides. When I square this side, I get rid of that radical. I can square that side too. So I am left with the square root of x plus 2 squared, which is just x plus 2. On the other side, negative x squared is negative x times negative x, so you get positive x squared. Alright, now what I'm going to do is continue to solve by subtracting x and subtracting 2 to both sides. Getting 0 on one side of the equation and the quadratic on the other. So I'm going to have to move over here. But what I have is x squared minus x minus 2 equals 0. Can you think of two numbers that multiply to give me negative 2 to add up to give me negative 1? Well, hopefully x minus 2 and x plus 1. Set each factor equal to 0. X minus 2 equals 0. X plus 1 equals 0. Solve by adding 2 on this side, subtracting 1 on that side. And now I get x equals 2 and negative 1. Alright, let's double check real quick. When I put that 2 in there, I get 2 plus 2, which is 4. The square root of 4 is 2, plus 1 is 3. And is 3 equal to 3 minus 2, which is the square root of 1. I do something wrong. 4, which is 2. I think I did something wrong. 1 second. 2 plus 2 is 4. Square root of 4 is 2. Plus 1 is 3. 3 minus 2 is 1. Square root of 1 is 1. Doesn't seem to work. Okay. I'm going to say, nope, that doesn't work. I'm going to check x equals negative 1. Put in negative 1. Negative 1 plus 2 is 1, so I get the square root of 1 plus 1 is 2. And is that equal to 3 minus negative 1, which is going to be 3 plus 1 or 4, which is also the square root of 4, which is 2, and that one does work. So the only answer here is x equals negative 1.